Hello everyone, welcome to Simplilearn's YouTube channel. Today we will learn about Subquery in SQL. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
Just for a quick info, if you want to upskill yourself to master SQL for data analytics and land your dream job or grow in your career, then you must explore Simplilearn's SQL certification course. Simplilearn offers an industry-recognized SQL training and certification program for aspiring SQL developers and data analysts. Through this program, you will gain knowledge and work-ready expertise in skills like real-world problem solving, data analytics, and MySQLWorkbench, along with many others. That's not all, you also get the opportunity to gain an engaging learning experience featuring live demo sessions and real-world examples. You will also get dedicated live sessions by faculty of industry experts from top-tier product companies, along with the academicians from top universities. After completing this course, many of our learners have transitioned into a data analyst role or a SQL developer role as a fresher, or moved on to a higher paying job profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find the link to the SQL certification program offered by Simplilearn. So without further delay, let's get started. So SQL Subqueries. So subqueries in SQL are majorly of three types, which are Scalar SubQueries, Multirow SubQueries, and Nested SubQueries in SQL. So when it comes to Scalar subqueries, it'll return one row and one column. And when it comes to multi-row subqueries, there are two types. It can either give you one column and multiple rows, or multiple columns and multiple rows. And the last one is almost kind of self-explanatory, which says it is just a subquery inside an already existing subquery, right? So without further delay, let's get started with the MySQL Workbench, load our dataset to the MySQL Workbench, and try to query some subqueries based on the use cases that we are able to build on the dataset that we are using, right? And this might be an interview question, so where exactly can you use a subquery? So you can use a subquery along with the where, along with having, along with between, along with a select query, maybe insert, right? There are multiple possibilities. Just try to name a couple of them, maybe a 4 or 5, which makes you stand on the safer point during your interview. Now, let's get started with the MySQL Workbench. Now, here we are. The first thing that we will be doing is load the dataset. So just click on this new schema. So new schema is nothing different from your new dataset. So let's name it as Superstore and apply. It requires lowercase, so let's proceed with the lowercase as well. Not a problem. There you go. You have the new dataset or database. Now you need the dataset. So that dataset needs to be applied to the table. So currently we don't have any data in the table. Go to the import data wizard, browse, and downloads, and here somewhere I have SQL data. And remember to save your Excel data in the form of the comma separated file as CSV, and ensure that all your data table name and the column headers are compatible with MySQL or SQL. So basically what's the problem is, let's say you have some maybe the difference in naming convention, row space ID, right? So that could cause a problem when you are kind of trying to write a statement, right? So here I've already done that, row ID, order ID, order date. So I've replaced with an underscore wherever I found a space so that it becomes automatically SQL compatible, right? Now the first row might be having a small error due to the import function, but that's something that we can fix. So let's also check other column names or column headers over here. So every other column header looks absolutely fine, but the first one, which happens to be a small import error, but that's something we can fix. So go to the next and press on next. So this is about 9,000 to 10,000 rows of data, which might take a little while, but that's not a problem. Let's wait gently. There you go. The data got successfully imported. Now the next step is just click on the next here And yeah, therefore we have our 9,987 records imported successfully. Finish that, and we can close this schema. And now refresh the dataset here. Just right click and refresh all. And there you go. You can see the arrow mark here. Just click on that. You can see the Excel dataset. So here we have all the columns and remaining things what we require. So here are the columns. Now let's quickly use the dataset. The dataset name is Superstore. So this is the Superstore dataset. So we have also named the database as Superstore. Just run it. Now we have the full access of Superstore. Now you can just run the select star from the table name is Excel data, and we have query ready, and just run it, and we have the entire table right here. Yeah, so remember we were supposed to change the row name, right? So you just hover over this, and I think you'll get an option of copying the field name. Copy the field name. Now use the alt table Excel data rename column to row. Go. So we have done it. You can just run this query once again and make sure that everything is fine. There you go. Row ID. So far so good. Now let's get started with the subqueries. So as we discussed before, there are 3 different types of subqueries. Basically, Scalar SubQuery, Multirow SubQuery, and nested subquery. So let's start with the Scalar SubQuery. So there you go. Now we know Scalar SubQuery will give us 1 row and 1 column. So according to that, let's try to devise a use case. So let's find out the list of customer names that made a purchase above an actual average, right? Let's say we have the customer names and customer IDs. Let us say that, okay, let's find out the average sale, the overall sale, right? So there might be a few customers who might have basically some deep pockets, basically they're rich, and they might have, purchased some goods from the store, billing more than the average of overall sales, right? We need to find out such customers so that we can basically offer them some discounts and maybe a few more coupons, something like that, so that encourage them to shop a bit more. That sounds like a use case, right? So let's get ahead with that. Let's write the use case. So that's our use case right there. So first we need to find out the average of all the sales. So let's write the query. You write the query by select and an aggregate function which is average avg sales. So we have sales data here from table. Let's copy the table name Excel data semicolon. So this is our first query, or you can also call it as an inner query. So the average sales is about $294, right? So this is our average sale. Now we need to use this inner query. We need to devise this as an inner query and write an external query where we will find out the customer names, right? So let's write that. Select customer name, customer underscore name from Excel data. So you can see that I'm using the naming conventions in a different way. The keywords are all caps, and the table names and the column names are in small, right? So this makes things easier for anyone who's reading your code. So they'll understand that this is, a variable name or maybe a keyword. So they'll easily identify that. So this happens to be our outer query. So select customer name from Excel data where sales are greater than average of sales. This is our inner query. So you can name it as outer query, and we have already named it. No, we didn't, but we can name it as inner query. So this increases the readability of your code, right? So now if we execute this, we can get the output. So we have so many names here, but we happen to require, as we can see, we have duplicate entries of data, right? So we can make minor changes over here. What we can basically do is use a group by function and let's group them by customer names. And as a fact, we know the sale number, right? So let's include sales as well, so that we have customer name right in front of the sales what they made, and we can have a clarification if they cross this 294 number, correct? And since we're using group by, and in that situation, let's replace where with having. Now this is a correct query. So that's the explanation, right? So you can use subqueries along with have, along with where, along with having, and select, right? So let's try to execute this code, and we should be having the output ready, right? So we have our customers, and they have made multiple sales here, right? So they might have come to the store multiple times, and they might have made multiple sales, right? So here they have made multiple sales which are above the given sales number. Now let's proceed with the next query, which is the type of query is multiple row subquery, the second type of subquery, right? So let's rename this as multiple row subquery. So why am I doing this? So this document will be an open source document, so that you can have access to this document while you are learning. This will be linked in the description box below. You can just download the dataset. You can just download the query document and try to follow us for a better learning experience. Now let's go with the problem statement for this. So it is something which gives you multiple rows and multiple columns in return. So now let's try to build a use case for this. So the use case is, let's try to find out, okay, let's execute our first query over here. So we have city, right? We have city, state. So now let's try to find out that particular state which has highest sales, right? So let's try to identify any state which has more than 100 sales. Let's say your manager just gave you a use case to find out that single state where we have maximum sales happening. So the sales number should be nothing less to 100, so that we can target the product more, right? So for that particular situation, we can go with this particular solution. So again, there are two parts of this, and firstly we will try to find out distinct states names, right? Select state from Excel data where sales is greater than $100 float. So this is the inner query. Let's execute this. So these are the states. Now we wanted a distinct allocation, right? So let's try to roll this state under distinct function, so that we have those distinct states. So one state might have faced multiple sales which are above $100, right? So we just wanted to know which are those states which are giving sales at least above $100. So that's the inner query. Now let's try to wrap it under an outer query, where we will try to find out the same thing. And we can do one better. So what we can do is, since we already had multiple states in the list, let's try to find out a city or state that has less than $100, right? So why don't we do that? Let's select distinct states or state from Excel data where state is not in, where state is not in, where state not in is not required over here. And you can open the bracket, and you can wrap this inside an inner query. Close this. There you go. And if in case you wanted to provide some indentation, you can also do that, and your query is done. Now if we execute, we can find out those states which are not yielding at least 100 sales. There you go. So we have a list of 4 states which are not even giving us 100 sales, right? So in these sales, you can do two things: either stop your store, or you can give some exciting discounts on your products, so that you can drive some motivation in the customers to buy some things. Now the next use case is, let's try to find out some product names from subcategories that get higher sales than all the products in their subcategory, right? So this is another example in multiple row subquery. So let's try to execute that. Let's write down the use case first. So we have the use case ready. Now let's try to write the query. Select product name. Let's also try to extract the subquery, right? That should be helpful. Subcategory, not a subquery. Maybe we can also extract sales numbers from Excel data, and let's try to alias them as E1, where sales is greater than, so this is the outer query. Now let's try to build the inner query. Select average of sales. We wanted to find out that product which is selling more than the average of all the sales, right? Sales, wrap it under the average function. From Excel data, we can alias it as E2. So why am I doing this aliases over here? Because there is a funny thing, not actually funny. So this is an important thing which you might have to consider, because these aliases will help us to write a query in such a way that the query will run only when it has some value from the outer query. So far here, if you run this query, the inner query, it will actually run without any error. And when you execute it along with the outer query, it will run, right? But in the current situation, the current query which we are writing here, it will not run unless it is clubbed with the outer query. How? Let's check it. So I'm going to write a where query right next to this, where E1 dot subcategory is equals to E2 dot subcategory. You can just copy paste this to save time in the interest of time and close the bracket, right? Now, if you try to execute this inner query, it will never execute. It will throw an error, right? Now, if you club this along with the external query, it will run. So if the query is heavy, sometimes we might lose the connection to the data set or the server. It's okay. At times, we can just optimize the query and try to get an alternate result. So you can see it's running over here, fetching. We should be receiving the output shortly. There you go. We have the data. So based on that particular subcategory, we have accessories, we have labels, appliances, right? So it's like you are grouping all the categories available in your dataset, and you're calculating the average of sales happened in that particular subcategory. Now you have that average number, right? And if any product in that subcategory is selling above the average of that particular subcategory, we are extracting that product name, right? So SanDisk, numeric keypad, Bluetooth. So these are some products which are outselling in those respective categories. So we're basically trying to find out the best performing products of all the individual categories, right? Now let's proceed with the next query. Let's proceed with our third type of subquery, which happens to be the nested subquery, right? Now let's devise a use case for this. So the use case is find the customers who have placed orders for products from specific category and whose total sales exceeded the average sales of all the customers, and who have placed orders for products from the same category, right? So this is the use case. Now we can devise a solution in 5 steps, as I have mentioned already here. Identify the customers who have placed orders for products from specific category. That's the first step. Then, for each of these customers, calculate total sales for products from the specified category. And then, calculate the average sales of all customers who have placed orders for products from the same category. Fourth step is compare the total sales of each customer from step 2 with the average total sales from steps 3. And lastly, return the list of customers whose total sales exceeded average of all sales. Now, this is a little complex to understand, but again, not to worry about. We will devise the solution one step at a time, right? So we will write the query inside a query inside a query, right? So we will be also using some join clauses in between. So that's how it's going to work. So let's quickly write the query. So the first query that I'm going to write is find the customers, identify the customers who have placed the orders for products in specified category. So select customer ID. Let's also try to calculate the sum of sales that they provided. sum of sales, and let's call it as an alias as total sales, right? So far so good. From, okay, let's try to add an underscore. I missed that. Excel data. So the thing is, for a specified category, right? For a specific category. So the query is a little interesting here. So okay, let's quickly run our query here where we will identify what categories we have, right? So select category from Excel data, right? So we will identify which categories we have. So we have office supplies, technology. Okay, let's try to identify it as distinct so that we have the unique names of our categories. So now we have the unique names of our categories. We overall have 3 categories. Now the use case is they want to find out the sales from a specific category, right? Now let's provide the category as, I don't know, I like technology. So let's try to add the specific category as technology from Excel data where category is equals to, remember the double quotes or single quotes because we are using dealing with character type data type. So technology, or you can just copy field, right? So we don't want to take any risks here. That's the first query. Close and try to execute. Yeah, we missed group by, so what you can do is just add a group by. Let's group by customer ID. There you go. So based on the customer ID we have grouped it. Now this would be our inner query, and before we close it, we will alias it as customer sales. Okay, that should be the good name for it. So close this using a bracket and also begin this using a bracket and name it as customer sales. There you go. So the first part of it is done. Now we are going to implement the join function. Now based on what are you going to join this, we will be using the same query. We will be making a mild modification onto it. E1 dot customer ID. Let's copy paste. And this E1 dot customer ID should be equals to customer sales dot customer ID. So far so good. Join. We will copy paste the same query over here. This should be our inner query, and the outer query, try to select average of total sales, average sales from, and try to make some indentations so that it's easily readable and understandable. So I don't think we will be needing the customer ID here. All we need is sum of sales. We will name it as total sales from Excel data where we have the category. Okay, we have grouped it, and now let's close it and alias it as average sales. Okay, on customer sales, okay, we will join this on customer sales dot total sales, and this should be greater than the average sales of that particular category. Sales dot average sales. So far so good. Now we have devised the inner query and outer query. Now we need to take care of what are we going to extract from this, right? Now we want to extract distinct names. Okay, this might give us a lot of names, so we want distinct names, distinct of E1 dot customer ID, comma E1 dot customer name as well. So let's go with customer ID and remove ID and type down name, and we are extracting this from Excel data. Let's alias this as E1. This is our E1 table. Okay, and now we are going to join this. There you go. Now let's try to execute our query. So we have taken care of all the indentations and subqueries and nested queries. And if we run it, we should be getting the data. There you go. So we have extracted, the required. Find the customers who have placed orders for products from a specific category, so technology category, and whose total sales exceeded than the average total of all the other customers. So in the technology segment, the average sales of all the other customers should not be, so there are specific customers who bought a lot of technology stuff, and their sales is actually more than the overall average of all the other customers who placed technology orders in the same segment. So that's what we have found here based on their customer ID and customer name. So we basically executed all three types of subqueries, which is Scalar SubQueries, Multirow SubQueries, and nested subqueries. And that brings us to the end. And if you have any queries regarding any of the topics covered in this session, or if you require the demo document and any other dataset that we used in this session or the PPT, please feel free to let us know in the comment section below, and our team of experts will be happy to resolve all your queries at the earliest. Until next time, thank you for watching and stay tuned for more from Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.